All right, part 3 of the kinematics of harmonic motion here. We got to take care of a few definitions. There's a lot of little equations in this unit, and you want to just try and keep them straight. Okay, so let's talk about the time for this to go back and forth one round trip is going to be called the period of this thing. So the period. We're going to define the period. We'll shorten it with a capital T. Period is the number of seconds per cycle. Or the time for one round trip. But it will be in seconds usually. And it will be seconds per cycle. We sometimes also talk about frequency. Frequency is designated with a lowercase f, and we're going to define that as that's how many cycles you make in 1 second. So it's the cycles per second. Now if you look at these two, it's pretty easy to see that if this one's seconds per cycle and that's cycles per second, that indeed the period is equal to the reciprocal of the frequency or vice versa. All right, frequency, cycles per second has a name. Sometimes we call it cycles per second hertz. 1 hertz, abbreviated HZ, is equal to 1 cycle per second. All right, there's one more term that we want to know, and that's called the angular frequency. An angular frequency is going to be designated with an omega, and it's going to be how many radians per second. Now you might think, gosh, radians, this isn't going in a circle. How come we're talking radians if this isn't going in a circle? But if you remember the original picture of this thing, we looked at circular motion, and the omega, this omega, the radians per second that this is going around, is equal to the angular frequency of this. So the angular velocity is in radians per second, and so is the angular frequency. Now it might bother you that this isn't going in this one's not going in a circle, and we're still saying it has some radians, but 2 pi radians is 1 cycle. That's all we're going to say. So 2 pi radians is 1 cycle. So just as a sine graph, here's a sine wave. It has a cyclical nature to it. You know, it's getting done with a cycle in that's a cycle, and it's if this we call x and this we call theta. Then it's getting done with a cycle in 2 pi. Okay, so 1 cycle is equal to 2 pi radians. Okay, circle or simple harmonic motion, it's the same thing. Okay, now let's take a look then. We can say that omega was delta theta over delta t. But how many radians do you go around in one period? If you go 2 pi radians, then in the circle that was cast in the shadow, then that will take a time of 1 period. So 2 pi radians per second, this is called the angular frequency. Okay, so omega is 2 pi over the period. It's just like the frequency is cycles per second, this would be radians per second. And since omega is equal to 2 pi over the period, and the period is 1 over the frequency, then it looks like the omega is also equal to 2 pi f. So there's a lot of little equations to keep track of. And and you just want to have a handle on all these. Okay. So again, what is the unit for the period? It's seconds per cycle. What's the unit for frequency? It's cycles per second. What's the unit for omega? Angular frequency. It's not called angular velocity in simple harmonic motion. It's called angular frequency, and it's going to be radians per second. See how this gives you radians per second? And so does this. All right, that's all I had to tell you. A few short videos here. Thank you.